Today we're graphing rational functions, and this is a pretty lengthy process. We have to check for a bunch of different things that are going to happen in your graph in order to help you construct your graph. So first thing you want to look for is, are there any vertical asymptotes? Does your function have any vertical asymptotes? So the way that you check for vertical asymptotes is you find the values that make your denominator equal to 0. So look at your denominator and see if there's any way that you can make it equal to 0. So on our example, y equals 2 over x minus 3, we have a vertical asymptote at x equals 3. Because if you plugged 3 into your denominator, it would make it equal to 0. So there's a vertical asymptote at 3. The other thing about vertical asymptotes is that there's certain behavior depending on the degree of the power of the asymptote. So say you had y equals 1 over x minus 3 x plus 2 squared. So there's two vertical asymptotes on this function, one at 3 and one at -2. And if you notice, the degree of this vertical asymptote is 1, which is odd. The degree of this vertical asymptote is 2, which is even. So if the degree of your vertical asymptote is odd, here's your x and y axis, so here's your vertical asymptote. Your function is going to approach the asymptote going up on one side, going down towards the asymptote on the other side, or it might look like it's going up on the right and pointing down towards the left. So as you approach your asymptote from the left to the right, they're going in different directions. One side is going up towards the asymptote, the other side is going down towards the asymptote. That's when your asymptote has an odd degree. So for example, in this one, x equals 3 is our vertical asymptote, and it's odd. Even your function will point in the same direction, up towards the asymptote, or down towards the asymptote, like this. All right, now we're going to talk about how to check. That bell is so long. Okay, how to check for x-intercepts. So to check for where your graph is going to cross the x-axis, you need to look at the numerator. Where is it equal to 0? That says num for numerator. So an example would be like y equals x plus 2 over x plus 3 times x plus 4. Well, we know that this has two vertical asymptotes at -3, -4. But to check for where it has x-intercepts, you set your numerator equal to 0. So x plus 2 is equal to 0. Subtract 2, and so you have an x-intercept at -2, 0. So look for vertical asymptotes in your denominator. Look for x-intercepts in your numerator. Next thing is how you look for horizontal asymptotes. Whoops. How do you check for horizontal asymptotes? This is where you're going to have to look at the degree of your numerator and the degree of your denominator. So if the degree of your numerator is equal to the degree of your denominator, then your horizontal asymptote is y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So an example of this would be y equals 2x plus 1 over x minus 3. The degree of my numerator is 1. The degree of my denominator is 1. So my horizontal asymptote is at 2, which is the leading coefficient of my numerator, over 1, leading coefficient of my denominator. So my horizontal asymptote is at y equals 2. Situation 2 is where, whoa, I keep overcooking, where the degree of your numerator is less than the degree of your denominator. So something like y equals x plus 3 over x squared minus 4. The degree of your numerator is less than the degree of your denominator. The degree of your numerator is 1. The degree of your denominator is 2. When the degree of the numerator is less than the degree of the denominator, horizontal asymptote is at y equals 0. That is your horizontal asymptote. The line y equals 0, aka the x-axis. And then the last situation is where the degree of your numerator is greater than the degree of your denominator. So something like y equals x plus 3 over 2, or y equals x squared over x minus 1. There is no horizontal asymptote in these situations.